We propose the 3D gaze redirection framework that incorporates an explicit 3D eyeball structure into the existing 3D Gaussian head avatar method. As 3D Gaussian splatting methods emerged, algorithms have emerged that leverage explicit Gaussian deformations to animate 3D head avatars. Previous NeRF-based approaches rely on implicit representation, making explicit eyeball rotation and translation infeasible. We propose a novel 3D gaze redirection framework that leverages explicit 3D eyeball structure. By integrating 3D eyeball structure into a 3DGS-based avatar representation, our model is able to generate realistic gaze-redirected images with high redirection accuracy. To integrate 3D eyeball structure to Gaussian head avatar, we introduce EyeOffset MLP, which enables 3D eyeball structure to locate on anatomically correct place. For rotation, we explicitly rotate 3D eyeball structure using gaze vector. For Gaussians composing eyeballs, position of Gaussian is fixed to maintain structural stability, and other attributes are modified following gaze vector. For facial Gaussians, we follow the Gaussian head avatars method to optimize and deform Gaussians following expression and pose vector. Our method introduces additional influence factor lambda gaze to deform the Gaussians on the eye region. Gaussians near eyeballs are affected by gaze vectors to simulate subtle muscle deformations. Our gaze-guided deformation field enhances the realism of synthesized facial images, particularly eye region. We also introduced two additional loss for facial stream and eyeball stream to concentrate exclusively on facial and eyeball-related information. First, the eyeball loss ensures that eyeball-related Gaussians render the masked eye region only. Second, the facial loss regulates the facial stream so that the image rendered from the facial stream alone does not create artifacts in the eyeball region. Together, these losses enforce a clean separation of two distinct streams, resulting in higher quality gaze redirection. As a result, we are able to get realistic gaze redirected images with flexible eye gaze control. Thanks to the explicit 3D eyeball structure and the independent control of each eye, our method enables precise and per-eye gaze manipulation. It can generate photorealistic images even in challenging scenarios where the eyes exhibit cross-eyed or other unconventional gaze directions. Thank you.